lipids that cannot be broken down or cannot be broken down into smaller substances, smaller molecules by the process of hydrolysis. There are types of nonsaponifiable lipids. First, we have the terpenes. Second, prostaglandins and steroids. Terpenes these are any of the various isomeric hydrocarbons and are found in essential oils, resins, and balsams, and also includes conifers, and these are used in organic synthesis.
And what a terpene or a terpenoid is. Terpenes are made up of isoprene units. This is isoprene right here, a 5-carbon molecule. And the thing that we are concerned about is that it's attached in this structure. It doesn't matter about the functional groups. All you have to have an isoprene unit in a terpene is 2 carbons attached together like this, and then 2 as like that. We call this part the mouth. Looks kind of like a Pac-Man mouth right here. And then this part is called the tail. Every terpene has units of isoprene in it. For instance, if we look at citronellol, you can see right here, 1, 2, there's the mouth, and then 1, 2, that's the tail. Then here's another isoprene unit. 1, 2, that's the mouth, and then 1, 2, that's the tail. And so this is a terpene because it fits the isoprene rule. You can have rings form, you can have them be open chain. This is geraniol, it's very similar to citronellol. And you can see it doesn't matter what functional groups are anywhere on here. If it has that basic carbon backbone, it's defined as a terpene. Here's limonene, that's what's in lemons and limes. That gives them that citrusy smell. And you can see here's one isoprene unit and here's another. And you can see the head here is attached to the tail here. Here you can see a tail is attached to a head. So we classify terpenes based on how many units of isoprene they have in there. A monoterpene has 2 isoprene units. A sesquiterpene actually has 3 isoprene units, and then a diterpene has 4 isoprene units. It's kind of confusing because you think of monoterpene, it would have 1, but it actually has 2. Everything's doubled. Di has 4.
Second, we have the prostaglandins. Prostaglandins are a type of nonsaponifiable lipids to which these are unsaturated cyclic fatty acids that are involved in organic synthesis. Steroids.
Have a fever? Maybe a headache. Many people choose to take acetylsalicylic acid, or aspirin, for relief of their symptoms. In fact, aspirin has been used by humans for more than 2,500 years, ever since some person realized that chewing willow leaves seemed to treat their discomfort. This is because willow leaves contain salicin, which is turned into salicylic acid in the body. Chemists such as Charles Frederick Gerhardt and Felix Hoffmann later experimented with salicylic acid to find ways of making it last longer and become less toxic in the body, which led to the creation of aspirin. Most people have experienced and appreciated firsthand the soothing effects of aspirin, but how does it actually work? The body has many ways to fight an infection. It could raise the temperature and cause a fever, making the environment inhospitable for any pathogen invading the body. In addition, immune cells in the body are stimulated to release a wide variety of toxic chemicals that can kill any invaders, as well as chemicals that stimulate more immune cells as backup, a process known as inflammation. Of course, the higher temperature and released chemicals also damage your own cells, which is why you may feel pain during a fever. Despite this, fevers are not necessarily a bad thing. It is a natural and usually effective way for your body to fight infection, and aspirin and other fever-reducing drugs should only be used if the fever has lasted many days or the body temperature is very high, both of which increase the risk of permanent damage to the body. So what tells the body to turn up the heat, or the immune cells to release their chemicals? Nobody really knew for many years, even after aspirin began to be sold. In 1971, more than 70 years after aspirin first entered the market, British pharmacologist John Vane discovered that a family of fat-derived molecules known as prostaglandins seemed to be responsible for causing fever, inflammation, and pain, and that aspirin treated these symptoms by preventing production of prostaglandins. For his breakthrough discovery, he was awarded the 1982 Nobel Prize in Medicine, which he shared with two Swedish biochemists, Bengt Samuelsson and Sune Bergström, who also did extensive research on these prostaglandins. How does aspirin prevent prostaglandin production? Understanding this requires figuring out the synthesis pathway of prostaglandins, which was accomplished a few years after Vane's discovery. Prostaglandins are derived from fatty acids in the cell membrane. These fatty acids are cut off of membrane lipids by an enzyme known as phospholipase A2. Afterwards, an enzyme called cyclooxygenase, as its name implies, creates a ring in the fatty acid and adds some oxygens to form an intermediate prostaglandin, which is further modified into a variety of different prostaglandins with an incredible diversity of functions. These functions include acting on the hypothalamus to increase body temperature, stimulating immune cells in inflammation, and sensitizing nerves to pain, as well as initiating clotting in blood, constricting and dilating blood vessels, producing mucus in the stomach to protect the stomach lining from stomach acid, and so many more. What aspirin does is that it stops cyclooxygenase from working, which blocks prostaglandin synthesis and results in temporary reduction of prostaglandin-induced pain, fever, and inflammation, until cyclooxygenase activity returns to normal. This inflammation doesn't have to just come from infections. Inflammation from some autoimmune diseases such as rheumatic arthritis can also be relieved using aspirin. However, since prostaglandins aren't just involved in discomfort as mentioned earlier, using aspirin also stops other body functions as well. Sometimes this is a surprising benefit. For example, one of the prostaglandins that aspirin prevents from synthesizing is thromboxane A2, which is involved in activating platelets to initiate blood clotting. This means by taking a low dose of aspirin every day, it becomes harder for blood to clot. This is extremely useful in preventing diseases caused by blood clots, such as heart attacks and stroke, and low-dose aspirin is actually recommended for older-aged people who have a higher risk of suffering from those diseases. On the other hand, aspirin also decreases production of protective mucus in the stomach, which means that stomach acid can burn through the stomach, leading to gastric ulcers and dangerous internal bleeding. Since there is also less clotting occurring, this side effect becomes even more dangerous. Therefore, taking aspirin to reduce the risk of heart attack or stroke is not recommended for people who are at a low risk of developing those diseases anyways, as well as people who have a tendency of developing gastric ulcers or have genetic problems with clotting, such as hemophilia. Some other possible side effects of aspirin include worsening of asthma in some asthmatics. Another family of fat-based molecules, called leukotrienes, can also be formed from fatty acids cleaved by phospholipase A2. These leukotrienes cause narrowing of airways and more mucus production, making breathing difficult. When cyclooxygenase is inhibited, there are more fatty acids available to be converted into leukotrienes, which sometimes exacerbates the symptoms of asthma. Finally, you may have seen baby aspirin on the shelves at your local pharmacy. This is not for babies or young children. Aspirin is not recommended for children because it may cause Reye's syndrome, which involves life-threatening damage to both the liver and brain. The mechanism of this disease is not quite understood, but almost 90% of cases involve children taking aspirin during a viral infection. Baby aspirin is called that because historically it was used for babies and therefore is at a lower dose. Nowadays, it is actually used to prevent blood clotting as mentioned earlier. Look for alternative fever relief drugs such as ibuprofen or acetaminophen if a child has had a fever for a long time. Speaking of other fever relief drugs, it turns out that aspirin is not the only drug that works by inhibiting cyclooxygenase. Other common drugs such as ibuprofen, acetaminophen, and naproxen also inhibit cyclooxygenase and therefore have similar effects as aspirin. You may recall from previous videos that steroids are also used to prevent inflammation such as in autoimmune diseases. Steroids work differently by inhibiting phospholipase A2, but also have multiple other functions that can lead to more side effects, such as Cushing's syndrome. Since aspirin and other cyclooxygenase inhibitors are not steroids and can still decrease inflammation, they are called non-steroidal anti-inflammatory drugs.
Steroids, these are naturally produced in our body. This contains 17 carbon and 4 ring systems. So there are many types, also subtypes of steroids. First, we have cholesterol. Cholesterol is the most fundamental and the famous steroids. Second, androgens. It involves in male fertility. This controls the development or regulates the development of male reproductive system and is involved in the secondary sexual characteristics it brings. Same as true of estrogen and progesterone. If androgens is for males, estrogen is and progesterone is for female, to which regulates the secondary characteristics or sexual characteristics in females. Third, we have aldosterone. This involves in the control of water and electrolyte balances. Cortisol, it involves in metabolism and controlling inflammation. For last two, we have bile salts. Bile salts absorbs fat-soluble vitamins and vitamin D. It involves in the bone deposition and regulation of calcium absorption. Thank you.
Bulk up is strong. But what even happens to your body when you take steroids, and are there major risks to performance-enhancing drugs? Every time you pump a weight at the gym, your muscles experience damage, but the body recovers by forming new muscle protein strands to repair the muscle fibers. Over time, these strands increase in thickness and number, and ultimately, if muscle protein synthesis is greater than muscle protein breakdown, your muscles will grow. The degree of growth is largely regulated by testosterone, which increases protein synthesis. It's why, generally, men have larger muscle mass than women, as they have higher levels of testosterone. Now, steroids are any compound with a specific 4-carbon ring structure, so the term steroid actually includes some chemicals that can be used to treat fever and headaches, and even sex hormones like estrogen and testosterone. But the type of steroid we'll be looking at actually mimic natural testosterone with the intention to enhance performance, and are used by more than 15% of gymgoers. Within a single day of taking steroids, the expression of your genes will begin to change. Steroids easily enter your cells and bind to the androgen receptor. At this point, they can move into the nucleus and attach to your DNA, which activates hundreds of genes to increase protein synthesis while slowing protein breakdown. In the end, people who take steroids can have 3 to 5 times more nuclei in some muscle cells. Steroids can also stop the differentiation of fat stem cells and decrease a person's body fat. Days in, and you're quickly increasing muscle size and strength while also protecting muscle fibers against damage, making steroids ideal for exercise tolerance and recovery as well. But continue to take them and your behavior may start to change. Because steroid receptors are found in parts of our central nervous system like the forebrain, hypothalamus, and pituitary gland, steroids can lead to the classic roid rage. A study of athletes taking steroids showed 20% developed higher manic and depressive scores than non-users. Mice given steroids over 10 weeks also become more aggressive towards other mice put in the same cages. Male mice also become more dominant and are more willing to compete for sex with female mice. But that sex drive may not translate to better sex. For female users, steroids can interfere with the estrous cycle and may decrease sexual drive. Masculinization can occur as well, with female users gaining deeper voices and starting to grow more body and facial hair. Male users may experience sperm cell abnormalities and decreased sperm count. Steroids also decrease natural production of hormones that are necessary for maintaining testicular size, meaning your balls will shrink. And since most steroid users follow a cycle of on and off dosing periods, natural levels of testosterone can be quite low at times, causing erectile dysfunction and decreased libido in males. 40% of male users also developed enlarged breast tissue as steroids break down into estradiol, which stimulates the growth of mammary tissue. Finally, steroids can cause a high level of acne in almost half of users and increase the risk of heart disease and stroke. So, yes, steroids will make you bulk up faster and improve your athletic ability, but as with most things, comes with a set of risks and side effects that you'll likely experience as well.
Work.